Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello and welcome to the latest episode of Lunch with Tech Leaders. My name is Derek DeYoungie, Vice President of Engineering at Right Brain Networks. I'm your host for today. Joining me is software and data consultant Tom Kowalski. Tom?
Howdy.
All right. And we also have a subject matter expert with us, Chief Technologist of Tag Bio and former Head of AWS Research, Sanjay Padhi. Sanjay?
Hi, good morning.
All right. And last but not least, our technology consultant, Joe Coleman.
Hey there. Thanks for the intro, Derek. Just a reminder to all of you listeners, if you have any questions at all whatsoever during the discussion here, go ahead and throw them in the chat, and I'll be sure to make sure that they're addressed and covered. So thank you so much, Derek.
Awesome. Thank you very much. So in today's episode, we're going to be focused again on AI and its impact on healthcare and life sciences. So we've got a lot to cover today. Go ahead, grab your lunch and buckle up. Yeah, so of course, the ongoing topic, right, AI and its impact on our world. It's always interesting. So today we're going to talk about life sciences. We have, like I mentioned, a subject matter expert with us. I think it'd be great to start off with just Sanjay, if you could introduce yourself and give us a little bit about your background, that would be great.
Sure, thanks. More than happy to. So first of all, thanks for inviting me. My name is Sanjay Padhi. I'm the Chief Technologist at Tag Bio. Tag Bio is a biotech company. Before that, I was in Amazon, AWS. I was Head of AWS Research. And before that, I came from CERN, which is a lab, it's an international lab out in Switzerland, many member countries out there. So throughout my life, we worked on data and how we get insights from the data. And today, let's talk about how the insights from data, not only you can get certain understanding of data, but also how to generate new technologies or new text. So we'll discuss a few other things. So let's get started. Okay.
Yeah, fantastic. So I think another good way to start here is just let's talk about what in our eyes are promising new areas of research coming out of machine learning for healthcare. Personally, I think the promise of individualized medicine and things like that are really interesting.
Yes, you're absolutely right. For a long time, AI is a term coined sometimes in 1950s.
Right.
So it's not a new technology. But what is new is about those algorithms, those machine learning, supervised learning, unsupervised learning, reinforcement learning, these terms that are long time ago. So what is new is the processing capability. The silicons are becoming at 5 nanometer scale, which means you can process a lot more at these new computing powers. What is new is that you can process a lot more information than you could 50 years ago. And what is also interesting is, for example, the society is changing. I mean, I can ask you a question. How many of you unlock your phone just looking at it? Almost all of us, right? I mean, how did it happen? I mean, people talk about privacy and this is going to kill us. I mean, privacy is a de facto. I agree with all of that. But society has accepted a new norm, right? That you can unlock your phone looking at your face. And this is very precise. It's not somebody looks like you can unlock. And that changes is now getting into the field of healthcare or life sciences. It has its challenges. For example, healthcare has its own way of handling data. Health records are centralized, highly decentralized. Regulations are there. In the precision medicine case also. Yeah, go ahead.
That's interesting that you're mentioning how the privacy has changed. So was it a lot harder in the past with things locked down? And you're saying it's now easier to share that information, and people are more willing to share their more personal information to have that, better build those models and get their better data to infer on.
It's a very good question. I mean, it's not that the technology changed. I mean, a couple of years ago, there is no way you could do a clinical trial, right, virtually. But COVID actually lowered certain barrier, and that helped us to accelerate many of the healthcare-related studies like clinical trials, connectivity, omics variables in clinical. That doesn't mean the data is really open and anyone can go and kind of harness it, right? It still has guardrails. There are many level of authorizations you have to go through. There are many level of security you have to go through in order to look into the data. But also technology changes also. Now we talk about federated learning, which means the data is not leaving the campus, you're sending the model. Now we are talking about confidential computing, where only your processor knows what is the secret inside it, but the same processor being asked a different question is not going to give you a private answer. So that's confidential computing. So the technology changes, the regulatory changes are there, the guardrails are still there. It's not like it. But there are also more social acceptance. You might have heard about virtual clinical trials. This accelerate, drug discovery process.
Yeah, it's interesting the conveniences that we trade off. And I think that's a great way to get the public more accepting of this. I think there was as mentioned, like a lot of stigma towards like, oh, we don't want to trust, but kind of those conveniences have kind of nudged the population into wider acceptance. And that's just happening through those conveniences. And I think, one of the things that I was really interested in when, researching for this was the idea of like who's specifically around like the training data. That's a lot of data, or it requires a lot of data to be fairly accurate in these life sciences and biotech, right? Where are we getting this data from, and who's signing off on it being okay to use? If we're just anonymizing our training data, like how far can we actually anonymize something like the genome?
That's a really good question, and that begs down to the concerns. So one of the genome, look at genomes. It's started with PCR, and you give a blood and kind of collecting, breaking what we call a bank of DNA, right? From that, we do family and secondary analysis. But at the end, if you look at the data, it's a text data. It's as simple as that. It's a text data. And recent advancements in large language model, text processing part. So for a long time, natural language understanding of processing was really important and excellence one of them. But these may not be able to generate certain patterns, certain mechanisms. So now people are trying to look into these genomes, but also connected with clinical information. So let me give you an example. Imagine you have a person who goes to the hospital every X amount of days, that's clinical information, right? He is being diagnosed with Parkinson's and he has certain behaviors. And at the same time, you can also look at his genome and have a given type of genome like LRQK kind of genome, which is kind of responsible for a given gene expression, and that can cause Parkinson's. So combining these two in a more algorithmic fashion can reduce the time for diagnosis from several years to very quite quickly. There's the RedCap project, which Bio and Parkinson's foundations are working on that. So my point is that there are technological advantages there. You put guardrails to access the data, but now when you're trying to build the model, you have to start putting guardrails on the model itself. because this model contains these informations which are being trained on. The second aspect is happening is that you can always train on model on general data like GPT-3 or GPT-4. This is general text from all over the world. It's not the specific text related to genome, related to clinical information, right?
Right.
And then you can take those large models like GPT-3 or BART or Bloom and fine tune it with your personal data. So your personal data still remains with you, as well as the model remains with you, but you're actually using a higher dimensional object called GPT-4 or Bloom or BART. These are large models, and still can train and get insights. Actually, you can generate the different ways. What are the different ways a gene expression can evolve? What are the ways different exomes can be evolved? There's fantastic studies which is done in protein folding. What are the different ways proteins I can find a signature which can help my immune system? I mean, humans used to go through wet lab to find those proteins. Now we are doing it using AlphaFold and Pyramids. So it is helping quite a lot, but again, those counter insights from the backend.
Yeah, that's something that like you mentioned, like Chat GTP or just the models that they're trained on. But what are your thoughts on the more personalized getting information, right? Like asking like medical questions to like a Chat GTP, and yeah, just the liability and things like that. Do you see that as kind of like a breakthrough where things are going?
I mean, there will always be liability, but what I think is that right now, ChatGPT is a fine-tuning model of GPT-3, right? It's a transformer model of some principles of parameters. And then you fine-tune it, put human in the loop by using mechanism for reinforcement learning, such that it doesn't speak profoundly or such that doesn't have any negative statement or something so that, right? So that's just one application out of just foundational model for GPT-4 it's what I think is what's happening, what will happen is many healthcare or large organizations will build their own model, adding these foundational models on top of it, right? So you take GPT-4, you add your personal set of healthcare data from your hospital system, you keep the model, you keep the data, and you integrate with that model called like My Hospital GPT. So then you can have a much personalized interactions with that objects, but also you can get much deeper insights based on the regenerative properties of those subjects. So, I mean, let me step back. A simple example I'll give you to clarify. So let us imagine you do a given analysis, right? So you train your data on your personal data. You ask the questions like, what is how much I spent in my hospital system when I go to the hospital, or what is for this particular disease, what is the cost associated with that? This is actually a separate set of analysis in the traditional world. Take a separate set of data, you train it, and then you get a inference of the results. But in the generative world, you're actually chaining them together. Since you have a big model, plus your personal data, you're actually chaining these questions together, so it becomes more interactive, more generated, and can even give you information which is not in neither of the data, because it's also capable of generating information. Like one single example you can try, and it's still fact that is there. If you go to ChatGPT, which is again, as I said, a more application-centered version of GPT-3 or GPT-4, ask a question that, you have a book, you have a computer, you have a needle, and you have eggs. How do I make a pyramid out of that such that it's stable? So of course, this embedding is going to tell you each property object, like a book or a computer or a needle or an egg. But it's going to build it'll going to make a generative model which is stable enough, learning from this embedding stuff. So those generative capabilities are still there in this foundational model. And the goal is how do you harness it for healthcare?
All right. That's a lot of information, a lot of thought-provoking ideas here, right? Um, and I think that we're about to see a massive wave in our healthcare industry with the use of these tools. Just as far as like the possibilities are really starting to come to people's minds, and the power's here, right? Like before, as Sanjay mentioned, that we just didn't have the compute power, right? And now we do, and then things are becoming more easy due to the research in machine learning. So I know we are limited on time. Sanjay, you're presenting at BioIT World today. Is that right?
Yes.
Yes.
So yeah, I plan to talk about some of these and how in TagBio we are providing a kind of a platform where you can take a big foundational model like Glue or like NMLA from Facebook or from GPT-3 or GPT-4 from OpenAI, and then combine it together with your personal, for example, clinical trial data, drug discovery data, healthcare data, so that you build your own particular model. I'll show some demos also how you can ask more personal questions. Of course, we cannot use more private data, but I'll use some example data to show you how you can ask more private and exact question about clinical trial or cross clinical trials. So we are building a platform which will do your private model, allow you to keep your own data, which allow you to keep your own model, but it will take the best of both worlds, like take the large foundational model along with your private data to derive insight, ask follow-up questions, to even get new generative answers which we never thought of. So, for example, what are the proteins, right, which is responsible for my immune system? How can I generate a new one between combination of them? So, things of those things people should be able to dive. So TagBio is kind of moving in those directions. So, given that we work with like a product and things like that.
So yeah, it sounds like things are going great, right? The more compute, more access to the data. What are some of the challenges that you're having right now?
Yeah, there are a lot of challenges in my place. The first challenge is that you can think about all of these models, given its generative nature, we have to use it responsibly, right? So that's one challenge, how to tell the mass to do that. Second is what people call FAIT, fairness, transparency, accountability, and ethics. I think that needs to be built into it. Third challenge is that, all the life sciences or this particular industry is built on what we call public or reference data. Government-funded large organizations like the National of Health, where we got 1,000 genomes data or data like all of us. So this public funded organizations provided all of the data, but the models are currently all commercial, right? So there is no open public funded, let's say, models where people can play around with. So for a long time, we sent down the footprint of these government-funded information and data sets, as well as for a long time processing power. Now, very few foundational models can be built by these organizations because they have capacities like the hyperscalers. So those are the three challenges where you have to take a foundational model from somewhere, but then do you want to send your private data to those foundational models like GPT-3? Yeah. Those are challenges. And the last, we talked about social acceptance. And then also how to make the platform easier for people to more people to do it, all these kind of fine-tuning. We should sometimes talk about there are many ways of fine-tuning, particularly adaptive prompt engineering. We should talk about that at some point. But those are, I think, some of the challenges. I really think government should find a way to build foundational model for general maps and like an open source way, which is helpful. I mean, open source foundations as well as reference data sets are backbone for the country.
Absolutely.
So we need more engagement with that. Currently, there is not a single foundational model other than one from Bloom by a French supercomputing center plus three of the research organizations in France. That is not. Wow. So it's all commercial and you cannot lease it without sending a private data.
I don't know how, You know how that works. It's got to be funded. People want their investments back, right? But yeah, we're going to be looking to the colleges and stuff like that to really start, driving the open source community, I would hope, right?
Absolutely. And also open source community needs close computational power, which hyperscalers have, right? It's not only the data you need, but you need, thousands of GPUs, thousands of high processing infrastructure to train this model. So it's both. I think the public, as I tell many times, the public infrastructure, public transportation infrastructure, need to be strengthened based on which big corporations are built, right? And that's still lacking in many of the key areas.
All right.
Yeah.
Well, I want to be respectful of your time. Make sure you get on stage there, Sanjay. I really appreciate you having coming out and speaking with us. Hopefully, we'll be able to do this again soon.
Definitely.
Any
Thanks,
closing
Derek.
thoughts?
No, I'm really enjoyed this conversation. I'm looking forward to talking to you all. Thank you so much for inviting me.
Yeah,
Thank you.
absolutely.
Thank you.
All right. And then, coming up next week, with Lunch with Tech Leaders, we will be doing a discussion on serverless data stores, Dynamo, Aurora, and more. So as always, come on back and check that out. Thank you, everyone.
Thank you.
Thank you. Take care.